Okay, so sigma notation. So a sigma is a Greek S. Looks like that. Kind of looks like an E. You've probably seen it, like if you watch movies or go to a city that has a university with fraternities and sororities, they use the Greek symbols. So the Sigma Alpha Kappa fraternity. So when I lived in Toronto, I live not far from U of T, and I'd walk by and I'd think, oh, there's all those math symbols, but really they were fraternities. So in any case, that's the sigma notation. And so we'll use that a lot we're looking at it now, but you'll use it more in Math 20 and Math 31 and Math 30 next semester. And Math 31, you'll use it more there as well. Doesn't go away. The good thing about sigma notation is it's a fast way of showing a series. It means the sum of the terms represented by whatever formula we put in here. Okay? So we're given a series 5, 11, 17, 23, etc., etc. Determine the general term in simplified form. So that's just the term, not the sum. So Tn is the first term plus, we're adding, no, what are we doing here? We're adding 6 every time, yeah. Plus n minus 1 times 6. Okay, it's arithmetic. And we want to collect like terms, or expand and collect like terms. So that's going to be 6n minus 1. So that's your general term. Okay, now what we've done here is shown a bunch of terms for you. So take a look. This is 6 times 1 minus 1. This is 6 times 2 minus 1. So this is term 1. This is term 2. This would be term 3. This would be term 4. This would be term 5. Term 6. Term 7. Okay? So another way to express the sum of 7 terms, each of the form 6n minus 1, is with that sigma notation. Now I just need to erase a little bit here, just because I covered it up. Let's keep that. So notice it's going from 1 to 7, because the first term is when n equals 1, and the 7th term is when n equals 7. All right, so that's your general summation notation. So that represents this sum without having to show it all out. Okay, so sigma is the Greek letter. Oh, that is the Greek letter sigma. And it stands for the sum. 1 is we call it the lower limit of summation. So we begin summing when n equals 1. 7 is the upper limit of summation. We end summing with n equals 7. And 6n minus 1 is the general term of the series. Okay? And so you will find that sometimes in sigma notation we might not start at 1. Okay? We still would have a first term, but it's not going to relate to when n equals 1. So you do have to be aware, if you're given a series in sigma notation, the first term isn't necessarily when n equals 1. It's whenever this value starts with. Okay? So most of the times it is, but sometimes it's not. So for the series given there in question 1, write it in expanded form and evaluate each term. So I want you to write it out the long way and then evaluate. So I'll give you a couple minutes to work on that. Okay, so you just notice how I just wrote this out for each value of n, starting at n equals 1, and then I evaluated that. You can tell from this that this is the general term of a geometric series. Sometimes whatever formula is here isn't necessarily for arithmetic or geometric, right? This could be for any particular series that has a formula. It could be n squared. It could be n squared. It could be 2 to the n. And so this is pretty easy to see that that's compares to Tn equals T1 r to the n minus 1. Okay, but sometimes you can simplify things as well, and it won't look exactly the same. So just remember that. So looking at this, we can tell we keep multiplying by -2, so it's geometric. And what is the sum? Okay, well, obviously in this case, we could add them all together. 3 minus 6 plus 12 minus 24 plus 48. So what's that going to be? 24. If I start from the right, 24 plus 6 is 30. So should be equal to 33. Let's do the formula. We've got to practice that from last week. Okay, so this is 5 terms. So S5 is, remember the formula, first term, 3, times the common ratio, which is -2 to the 5, minus 1 over -2 minus 1. So -2 minus 1 is -3. So those actually divide out to give you negative. And then bracket, that's -32 minus 1. So that's going to give you 33. Okay, so the formula, or you could actually do that one pretty easily in your calculator. Now, the next one, I would not want you writing out 26 terms. Okay, so this one, we'll do S26. So first term is still 3. Common ratio is still -2, but now it's going to be 26 minus 1 all over -2 minus 1. So same deal, this divides into this to give you -1, so negative bracket. And then -26, I don't think I opened my calculator today. Just a sec here. I have my good calculator back, my good computer back. Okay. Oh, I can do that there. Okay, so I want to clear. And I want to go brackets. Bracket -2, close bracket to the exponent 26. Or just go 2 to the 26 because it's a negative inside the brackets and an even exponent. Okay, and then minus 1. Okay, and then, so that's a positive, but there's a negative out. So this is 67,108,863. That ends up being a positive, so overall it's negative 67,108,863. Okay. All right. You try the next one again. So now this index of summation is I. It's starting at 3. So that means that your first term has I equals 3. And you have to go up until I equals 8. So you write it out and then showing the substitutions and then simplify each term. So notice you're going from when I equals 3 to I equals 8. There are not 8 terms there. There are 6 terms. Okay, that index of summation are always natural numbers. Well, technically, I guess you could start at I equals 0. Sometimes that happens. So whole numbers. But they're never negatives. 26 minus 15 is 11. 6. I'll line them up underneath. So now look at the terms, state whether it's arithmetic or geometric. Well, to go from the first term to the side, so 6 minus 11 is negative 5. 1 minus 6 is negative 5. Negative 4 minus 1 is negative 5. So it's arithmetic. So the sum of the series, so remember, so there are 6 terms. So there's 2 formulas you could use. Same with the last one. We could have used the formula where we use the last term in it. So maybe I'll do that for this one. So it's going to be n over 2 times the first term plus the last term. Okay, now, again, there's only 6 terms, so we could do that in our head. 11 plus 6 is 17, plus 1 is 18, minus 4 is 14, minus 9, well, 14 minus 14 is 0, minus 9 is negative 9. So let's see if we get negative 9 here. And we do. Okay. Now, if we didn't have a last term and we had to figure out what it is, I would use the other formula. But so either one, it doesn't matter. Okay. Next one. So given a series expressed in sigma notation, write a rule to determine the number of terms in the series using the lower and upper limits of summation. So let's go back to that one. is this one here. So obviously when we started here, when we started at 1 and went to 5, there were 6 terms. All right. If we go 5 minus 1, we get 4, right? Oh, sorry, no, 5 minus 1, there was not 6 terms, that was the last question. This is question 1. So question 1, we started at 1, n equals 1 goes to 5, and we had 5 terms. So that's awesome, right? But that's if you start at 1. The next one, we start at 3 and go to 8. We do not have 8 terms, we have 6 terms. Well, like taking a look at this, 8 minus 3 is 5, so we would have to add 1 to it. Because really, if you're thinking about if we had 8 terms starting at I equals 1, then we're really just missing when I equals 1 and 2, right? So we subtract the 3 and add 1. Same as we can do it on this, we don't need to, but 5 minus 1 is 4, plus 1 is 5. So that's the rule. Upper minus lower plus 1. Okay, so for each series shown, state the number of terms in the series, determine the first 3 terms, and determine the sum. Okay, so take a look. We're starting at n equals 6. So the number of terms is 23 minus 6 plus 1. 18 terms. Determine the first 3 terms. So that's going to equal, when n equals 6 to start, so n equals 6 will be 2 to the 6, and that's your first term. Plus, then 2 to the 7, that's your second term. Plus 2 to the 8, and that's your third term. Okay, what are the actual values? So what is that? 2 to the 6 is 64. 2 to the 7th then would be 128. 2 to the 8th would be 256. Okay, now I want you to find the sum of that series. So remembering, it ends when the index is 23. Okay, so the sum of 18 terms, first term 64, in brackets, common ratio to the 18, minus 1 over 2 minus 1. So really that's going to be 64 bracket 2 to the 18 out of the exponent minus 1 divided by 1. You don't have to show that. Okay, so it is, what is that? 60,777,152. Geometric sums are pretty big. Okay. So next one, number of terms. Oh. We do have a fire drill today, just so you know. You can go outside at your house. So I will be done before 3:15 today. We'll probably be done shortly anyway. That was just my reminder. Number of terms equals 92 minus 28 plus 1. So what's that? 90 minus 70 minus 6 is 64 plus 1 is 65. Okay, then find the first 3 terms. So the first term is when n equals 28. So that's going to be 7 times 28 minus 3, the first term, plus 7 times 29 minus 3 is the second term, plus 7 times 30 minus 3 is the third term. And then find the value of those. So you can tell it's arithmetic. Basically, you can tell if your unknown is, or if your general term is linear, arithmetic. If your unknown is in the exponent, then likely geometric. If your unknown is quadratic or cubic, then it's neither of those, or any other polynomial. Okay, so then here, again, we're finding S65. So that's 65 over 2. You could put in 92 to get the last term if you wanted to, or just use your sum formula and go 2 times the first term plus n minus 1 times the common difference, which is 7. Really, on a test, you want to show that substitution, and then if you want to do it all in your calculator, I don't really care. I probably do the brackets first, so 2 times 193 plus 64, we do that in my head, times 7, 65 minus 1. Hopefully you can do that in your head. That's 834. So then I just go multiply 65 divided by 2. Okay. And then question 5, it says, write that series in sigma notation. So, look at the pattern. Is it arithmetic or geometric? Because then you use your term formula. That's what goes in the sigma notation. So, here looks like negative 6 minus negative 10 is 4. Negative 2 minus negative 6 is 4. So this is arithmetic. So T1 is negative 10 and D is 4. So your nth term is going to be the first term plus n minus 1 times the common difference of 4. Okay. Collect like terms, put it in descending order of degree. And always check. Okay, when n equals 1, do I get negative 10? Yep. when n equals, let's say, 4? Do I get 2? Yep. Really should be flat at the top. There, that's a good sigma. Okay, and you can use n's because it's representing a sequence. You can use i's. So common letters are n, I, J, K. Oftentimes, actually, when you get into math 30 and 31 and use it, we actually keep n separate because we might go to n, which means that's the nth term. So we often use i's, j's, or k's. So I'm going to use I in this case. So, but I'm going to start with I equals 1, right? Because we're going to start with our first term. If we're using our formula for arithmetic, then all we do here is copy it out, but use whatever letter you're using for your index of summation. And then what we still need to figure out is what it goes to. What's n? Which term is this? Right? So we have everything here, but which term then do we go to? So that's where, I'll just create a little bit more space here. I'll do it in green. So I want to know if my term value is 142, what's n? So this is your Tn equals 4n minus 14. And I know that nth term is 142, so I solve for n. So that's 156. And divide by 4. So that's 39. And you're done your sigma notation. Okay. So when you're using sigma notation, you just have to find the nth term, not the sum, unless you're actually asked to find the sum, right? So that sigma means this is representing all the terms with adding in between them. Then if it says, what is this equal to? Then you want to actually find the sum, right? It's showing the work for all of those terms. Is shortened in the sigma notation. So in question 6, a series of 15 terms is defined by the recursive definition, represented in sigma notation. So just write out the first few so that we can see, what we have here. So T1 is 29, okay? And it's a series, so I'm going to put the plus in between. And then the second term is the first term plus 12. So that would be 41. And then plus 12 again is 53. All the way up to the 15th term. Thing with recursive, we don't know what the 15th term is. We would need to know what the 14th term is. And then to know that, we need the 13th. So I'm not going to try to find the 15th term right now. Okay. Taking a look at it though, we know basically from this that this is arithmetic, where D is 12. T1 is 29. So we can find our general term formula. This was the recursive definition. Usually the better formula is the one that you can use for any term value. Recursive is really good. If you take computer programming, you're probably going to talk about recursive definitions a lot. So you use that because the computer goes back in and calculates it each time. So Tn is the first term plus n minus 1 times a common difference, and then you simplify that. Okay, now put it into sigma notation. Sigma, and again, I'm going to use I equals 1 to 15, right? Because we're told 15 terms, and then 12I plus 17. And I like to put it in brackets because maybe you're meaning the sum of 12I and then add 17. So I like to put that in brackets, the whole thing, your general term in brackets. Then you know that is for that sigma notation. Okay, and then sigma 6 times 1/3 to the k minus 1. So we're finding the value of that. That's an infinite series, right? We learned the sum of an infinite series the other day. It was T1 over 1 minus R. Okay, so we need to figure out what T1 is. And you might look at it and think, oh yeah, it's 6. Just always check. Maybe your value, your index is not starting at 1. Maybe this has been simplified somehow. So always do the first couple of terms. So when k equals 1, we would get, so 6 to the 1 times 1/3 to the 1 minus 1, plus 6 to the 1 times 1/3 to the 2 minus 1. Plus 6 times 1/3 to the 3 minus 1. So that's going to be equal to 6. That's going to be equal to 2. That's going to be equal to 1/9 times 6, which is 2/3. Okay, so it does turn out that your first term is 6. And that your common ratio is 1/3. So you finish that off. Okay, so it's going to be 6 minus 1 minus 1/3 is 2/3, or not 6 minus 6 divided by. And so that's going to be 6 times 3 over 2, which is 9.